Alright, hopefully that shows up okay on the camera. There's the laser dot here. It's going across my garage and bouncing off a mirror and coming back and hitting this target here. So now I will perform the experiment. So first of all, as a test, what I'm going to do is just blow across the beam, just so someone has pointed out that air currents might disturb the index of refraction of the laser beam. So I'm going to blow across the beam right now. So I don't see any movement of the beam. There now, it's very still. So I'm going to move the cylinder close to the beam right now. So it's just grazing the very bottom of the beam. Now there's no disturbance. And now I'm going to go to the side of the beam so that the tangential velocity of the disc will be just close to the side of the laser beam. There's a tiny little bit of shaking there. Now if I move away, it steadies. And if I move closer, there's a little bit of shaking there. Now I'm going to move the magnet close. That's just grazing. I'm just moving the magnet close, kind of in and out, just a little bit. I'm sorry, I only have one camera here, so I will show you what I'm doing here in a bit. But there's the beam moving a little bit, shaking a bit there. Sort of a fluttering. Now what does this prove? Okay, so I took the magnet away and I took the rotor away. Now the beam is back to being completely steady. I'm going to move the rotor just a little bit underneath the beam here. So it's just kind of, the laser beam is just going over the top of the rotor. Now to the side, the tangential side. Oh. Moving the magnet in towards the cylinder again. Looks like there's a little bit of fluttering there on the laser point, on the dot, which should be a dot, but of course I'm working with a dollar store mirror and just a laser diode here. There's definitely some fluttering there on the beam. All I'm doing is moving. I'll show you what I'm doing here. Okay, I'm going to shut it off. Okay, so these are the basic setup here was, so this was the laser I was using, just from this infrared thermometer, which is actually better than these laser pointers I picked up at a dollar store, and they weren't so good. The beam, by the time it went across my garage and back, the beam was diverged quite a bit, so it wasn't any good for that experiment. So this is the rotor here that I was using. It's just spinning on a little DC motor. this is made of bismuth powder, and this is epoxy. And that little chip broke off there, so previously, so that makes for more vibration. But even before that happened, there was still some fluttering with the laser point. And I was just running it off a 12-volt battery here. So what I was doing was, so the beam would cross along here tangentially to this, and then what I was doing was bringing this magnet near and away, near and away. And these magnets are N52 neodymiums, pretty strong. So that's basically what I was doing in that during that footage, just bringing that in and out. One thing I should try is just see if the magnets themselves affect the laser beam, the index of refraction. That's one thing I will do. Now I've just got the magnet assembly here. I have this like this because of other experiments I was doing, which I will demo probably in another video. But I just have these conveniently here. These suckers slammed together the other night, and getting them apart is a real chore. So anyway, let's see this thing. If there's any movement here, just letting it settle. Actually, I'll turn off the light. Okay, so there she is. I'm just going to move the magnet. So I'm just moving the magnet, kind of wobbling it across the beam there. And it looks like there is a little bit of, okay, so it's steady. I'm not doing anything right now. I'm motionless. Now I'm going to move it across with the beam. There's a little bit of fluttering there, I see. That's interesting. Okay. Now I'm not doing anything. Now I'll move the magnet briskly across the beam path here. It looks like a little bit of fluttering. Now I'll let it shine right through the center of the two magnets. So the beam is going right through the center of the two magnets. And I'm just moving it slightly. Wow, this is really interesting. I didn't think it could actually do this. I mean, the deflection is really tiny, but still, it's there. And just to recap, there was still a little bit, with just this disc spinning, there was a little bit of fluttering of the laser beam, which suggests that it might be slightly altering the path of the light. I don't want to make any claims, but I know that gravitational fields do alter the path of light, bending light, causing refraction, and that sort of thing. So, but this is a crude experiment, so yeah, I don't want to make any bold claims like that, but it kind of does look like something is going on here, which might be worth some more investigation. And it kind of follows up with the work that I was doing in my previous videos about rotating rotating metals, such as aluminum and brass. You know, all the nuclear spin, net nuclear spin active atoms, particularly heavy heavy types of nuclei, or heavier types of atoms, such as bismuth, copper, and probably a lot of other ones too. So my purpose for doing this experiment was just to, well, I just had this idea that perhaps through the combination of spinning this material and subjecting it to a magnetic field would cause the atomic nuclei to excited and aligned and also like jerked around, in technical terminology, jerked around, and that might perhaps be path of a light beam in perhaps in a gravitational sense, index of refraction through space, as gravitational fields are known to do. So aside from doing this in a vacuum, any thoughts or possible improvements on this experiment, you're welcome to post in the comments below. Appreciate it. Thanks.